All right, hello students. Today 3.5 is kind of another vocabulary driven section. A lot of what you're going to be seeing here is basically just focusing on some of these terms and then what these terms mean in certain situations. So when we're talking about symmetry, talking about the symmetry of lines, okay, determining whether each function has a line of symmetry and explain. Well, a line of symmetry basically means it can be cut into mirrored halves. Okay, if there's a line of symmetry that we can cut this thing in half vertically. Okay, so what that would mean is when you draw a vertical line anywhere, it's like it could fold itself over and be exactly the same. Okay, so let's just say if we try to put a line of symmetry anywhere on this line, okay, basically what that's like is this portion of the line is going to flip itself over. It's going to spin itself like 180 degrees to the other side, and then it's going to end up looking like this. Now, this ends up not being a line of symmetry, okay, because when we flip it over the line of symmetry, it does not match up perfectly with the other part of the graph, with the other half of that graph, okay? So on this line, no matter where we draw a line of symmetry, we're not going to have one, okay? It's not going to end up working. But over here on this one, okay, we can end up putting a line of symmetry right here, okay? Because this side of the graph, well, it doesn't really matter which side you decide to flip over, but you take one side of the graph, you swing it over 180 degrees the other way, and it's going to end up perfectly matching the other side of the graph. It would lay right on top of that other part, okay? So it basically, is there a line of symmetry is basically asking, does this graph kind of mirror itself on the left and the right from any certain point? And then where that line is, when they ask for you to explain that, this line is right between 1 and 2 on the x-axis. This is at x equals 1.5, okay? So that's a little bit of information that we want to make sure to have there, okay? Next couple. The line of symmetry for this parabola, that's what this graph is called. A parabola is symmetric. You can draw that line of symmetry right through this point that we call the axis, where that parabola turns around. Excuse me, not axis, the vertex. That vertex on that parabola where that parabola turns from one direction to the other, there will always be a line of symmetry through there. It will end up matching. So we are symmetric, and we are symmetric at that spot of x equals -2. So that line of symmetry is going up and down at x equals -2. And then this last one, we end up not having a line of symmetry. If you try to put a line in the middle here, somewhere around there, when you flip this thing over, it's going to end up going like that. It is not going to match perfectly with that other part of the graph. So we do not end up having a line of symmetry on that one. Okay? So I'll just erase that so that you can clearly see this graph on your notes when you look back. So the next slide. Now, what does this mean? Okay, so main cables of a suspension bridge are above the water X feet from the North Tower. Okay, so this is distance from the North Tower. And then this is the height of those cables along the y-axis. So basically, this graph is representing what's happening right here. Okay, so you're finding out, is it symmetric? Well, this looks like one of those parabolas. So we've got to find where the middle of that graph is. I'd say it's right about there. Okay, and that's where your line of symmetry will come in. So you got to tell me now, remember, we have to give that information of where that line of symmetry is happening. Well, if this is 1200 here, 2400, it looks like they're going up by 400 each time. So this one would be 1600 right there, and then half of that would be at this line of symmetry. I'd say that's looking at x equals 1800. Sounds a little bit more difficult to find with the way that graph's laid out, but we're at x equals 1800. Okay, so now the important part of what we're trying to do this year, you're going to see a lot of this explain or interpret, or what does that mean? We can tell these things on a graph, but what does that mean? Let's look at the actual situation. Okay, so 1800 what? 1800 feet from the North Tower 1800 feet from the North Tower, we ended up with our line of symmetry. And we can go a little further. We can go a little further in saying not only is it just exactly 1800 feet, if you notice, this graph goes from 0, right, to 3600. 1800 is half of 3600. Okay, so on this bridge, halfway in between those two towers, okay, is where this line of symmetry is. And that's typically where that's going to happen, is right in the middle. Halfway between the two towers is where you get that line of symmetry. Okay. So now this word extrema. Okay, again, another situation where we're really talking about a lot of vocabulary terms today. Extrema. Okay, so the extrema is, there's highs and lows within these graphs. Okay, when we're talking about a parabola has a maximum point or a minimum point, because that vertex is either the highest or the lowest point on the graph. With parabolas, we are seeing either like a big V type shape or like an A type shape. Okay, or I should say like a U or an A. So when we see this downward parabola, that is a maximum point at that vertex, because every other point is going down from there. And then when we have this upward parabola, that vertex is going to be a minimum point, because every other point is going up from there. Well, some graphs change directions more than once, okay? And that's where your local maximum or minimum are, okay? So the extrema of graphs, first of all, when we're talking about increasing or decreasing, this is pretty simple, okay? The one mistake where I see people make a lot is they see that this part is going up from right to left. They see it's going upwards on this left side, and they want to call that increasing, okay? But we always talk about increasing or decreasing going from left to right. We read our graphs from left to right. So as we look from left to right, okay, as we look from left to right, this first portion is actually decreasing down until it hits a local minimum, which we're going to talk about next. And then once it turns around, okay, so we're decreasing here, and then it turns around for a little bit and it's starting to go up until we hit another local, this one's a local maximum, okay? So as we're going from left to right from that point, we're going to be increasing. And then to finish, we start going down from left to right again. And then we finish with another decreasing segment of that graph. Okay, so you're always reading from left to right. Now, local maximum, okay, or relative extrema, relative maximum and minimum, are those points where it turns from increasing to decreasing. Wherever you turn from increasing to decreasing or decreasing to increasing, whatever, that is either like a peak or a valley, right? So this is going to be your relative minimum or your local minimum, okay? And then this one's going to be a relative maximum. This is like a peak and a valley. Okay, so wherever you turn, those points are the turning point. That's like the axis where we're turning that graph around. That's going to either be a local minimum or a maximum. Okay, so here, determine where x is increasing or decreasing. Remember, we're looking from left to right. Okay, so from left to right, we are decreasing all along this left-hand side of the parabola until we get to this one important point, okay? And then we turn back around and we're going to be increasing. So we're decreasing over here, and then we're increasing for the rest of it once we hit that local minimum. Okay, so that blue point is going to be your local minimum or your relative minimum. We're going to talk a little bit about that, okay? It's actually, since it's the minimum of the entire graph, this would actually be referred to as your absolute minimum. Okay, now here's the situation. It is at x equals 0. Okay, it is at x equals 0. And the actual value, the minimum value, is what the y value equals at that point. So the absolute minimum is at x equals 0, and then the actual minimum is going to be -3. Okay, we'll talk a little bit more about that as we see these next couple slides. So we're decreasing from left to right. So you have to tell me the portion of the graph that's decreasing. We were decreasing all the way up until x equals 0. So we were decreasing for every single value where x is less than 0. And then at 0, we turned around and we started increasing. And then we're going to continue to increase for every value where x is greater than 0. So you have to make sure that we're seeing those intervals, okay? Now you're going to be asked some questions in function notation, okay? You might be asked, what's the value at f of 2? Okay? F of 2, you are looking at the x value of 2, and you need to tell me what the value of that graph is. So for f of 2, we're going to go to 2 on the x-axis. We're going to see what's happening on the graph at that point, and it looks like the y value there is 1. So f of 2 for this function is 1. All that is a fancy way of saying when x is 2, what's your y? Okay? So now we're talking about extrema now, okay? So your relative maximum, okay, your relative maximum, no, minimum is first, sorry. Your relative minimum is at 0. It is at x equals 0. So then f of 0, for what the actual value is, it's right at the origin, so your value is 0 because your ordered pair there is 0, 0. So that's your relative minimum. Your relative maximum is up here at the ordered pair -2 and 4, okay? So your relative minimum is at x equals -2, and then f of -2 is that y value of 4.